Hi friends, today we are going to discuss about another interesting topic, that is, before that, welcome to Derin's channel, DERIN apostrophe S channel dot Raiden. Okay, coming to a point, the materials can be classified into three types. Any material in physics, it can be classified into three types. So what are the three types of materials? Conductors, semiconductors and insulators. We know what is a conductor, semiconductor and insulator. I am going to explain briefly what are the differences between why they are classifying these conductors, semiconductors, insulators as a types of a material. Let us consider the first factor, conductor. So what is the speciality of this material is, this material or element or thing which allows electrons or a charge carriers or a current to pass through it. So this material allows the charge carrier or electric current to pass through it. Before that, what is the charge carrier? We know the three fundamental charge particles: proton, electron and neutron. P for proton and E for electron and N for neutron. We have to use capital N for neutron. Even we can use for a small n also. Now, P, proton carries positive charge, electron carries negative charge and neutron, it is neutral. Charge carrier, that means proton carries positive charge, electron carries negative charge. In case of a conductor, the materials are allowing the charge carriers to flow from one atom to the another atom. That's why we are saying it is nothing but a conductor. And let us consider, does this conductor allows proton, electron and neutron? No. It is allowing only the proton and the electron, because protons and electrons are only responsible for production of current. What is current? The another way we can say, how we can explain current is flow of electrons, negative charge I told you, so E minus. Flow of electrons or flow of charge carriers is nothing but the current. So this conductor is allowing charge carrier, that is nothing but the electron or electric current. That's why it is called as a conductor. And how we can understand this conductor easily? Let us consider the three bands: conduction band, valence band. In between this gap is called as a energy gap. So in case of a conductor, the electrons are ready to move from valence band to conduction band. The electrons are moving from valence band to conduction band. So what is that electrons called? Valence electrons. Valence means what? Outermost shell electron. Outermost shell electrons. Or what we can say, it is nothing but the free electrons. Once the electrons gets energy, in case of a conductor, the electrons are moving from where to where? From a valence band to a conduction band. If the electrons are moving from valence band to conduction band, it requires some energy. So what is the energy gap? In case of a conductor, the energy gap is very, very less. Okay. So when the electron gets minimum amount of energy, the electrons are willing to move from valence band to conduction band. Once the electrons reach the conduction band, it starts to move. The electron starts to move from one atom to the other atom. So if it starts to move, I already told you, movement of electron from one atom to the other atom is nothing but what? Electric current. So this is an explanation for a conductor. Okay, so what are the example for a conductors? All metals are the good example for a conductors. But here let us consider the copper, iron and silicon. I am considering these three examples. What is the speciality of a copper is, most of the electric wires we are using copper, aluminum also. The reason is copper requires less amount of energy to move from valence to conduction band. So our work is easy to move the electrons from a valence band to a conduction band. So gap is very, very, very less. So once it reaches the conduction band, the electron starts to move. So the electric current is producing. Similarly for iron also. But silicon is not a silicon, silver. It's not silicon, sorry, silver. Silver is not a conductor. It is an insulator. The reason is, I'll tell you later, because before telling what is an insulator, you can't understand why silver is an insulator. So we can easily understand what is the conductor. The next fellow is opposite of a conductor is nothing but what? Insulator. What is this insulator? This material does not allow electrons to flow, so it is called as an insulator. That means if it is allowing, it is a conductor. If it is not allowing, it is an insulator. That's all. So let us consider the valence band. Here the conduction band. The electrons are there in the valence band. In case of insulator, these electrons are tightly bound. So if it is tightly bound means there is no movement of electrons. There is no movement of electrons. If the electrons are not moving from valence band to conduction band, there is no electric current at all. So there is no use of this insulator. We can't use this insulator. We can use this insulator only to where we don't want the electric current to flow. That purpose alone we can use the insulator. Let me tell you, in case of a conductor, I told you once the electrons gets, what is that electron called? Free electrons. Once the electron gets energy, move from a valence band to conduction band, and the energy gap here it is very less, I told you. But here the energy gap between the valence band to a conduction band is more. It is very high energy gap. So the electrons already it is tightly bound with the atom. So the electrons are not ready to move from one atom to the other atom. So it is not moving. So there is no flow of current at all. At the same time, what I told you, the energy gap is more for electrons to move from valence band to conduction band. So what is the example for an insulator? Plastic is an example, and rubber is an example, and even what is that? Air is a good example for an insulator. But I told you plastic, rubber, even paper is also an example for an insulator. Wood is example for an insulator. And what is this air is nothing but it has dual property. Dual property means the air, What is this dual property? Air can act as a conducting medium, but air is nothing but a good example for an insulator. Why it is a good example for an insulator? Because here there is no movement of electrons at all. But only in one particular case, the air is act as a conducting medium. When means in case of lightning. When lightning occurs, lightning is nothing but what? Fast moving electron, highly oscillating or high accelerating electrons. It's nothing but lightning. Lightning light, it carries electron. Fast moving, high oscillating, high accelerating electrons. This electrons has to reach the Earth's surface through a medium called air. In this particular case alone, air is act as a conducting medium. Otherwise, air is a insulator. So, conductor is a material which allows electrons to flow. Insulator is a material which does not allow electrons to flow. What is the material which is coming between a conductor and the insulator? Is nothing but the semiconductor, the third property of the material. Okay. The other name for a semiconductor, it is called as a partial conductor. Partially means it can allows the electric current or electrons partially. That is why it is called as the partial conductor. Here is the valence band and here is the conduction band, and the electrons move from the valence band to the conduction band. The energy gap is more compared to a conductor, okay, and less compared to a insulator. That is why it is called as a semiconductor. Partially it is allowing the electric current to flow. So what is the example for the semiconductor is germanium and the silicon are the best example for the semiconductors. Nowadays the electron chips, the computer chips and all, we are using a silicon material, silicon semiconducting material. Let us consider the diamond. This diamond is an example for a conductor or an insulator. So, in case of a conductor, I told you the electrons are continuously moving from a valence band to a conduction band. If the electrons are keep on moving from a valence band to conduction band, I told you if it is moving means electric current is producing. Current, if it keep on producing means what happened? The temperature will increases. If the temperature will increases, that will affect the property of the material. So that case, I want to resist the flow of electrons. So that case, what we are using a resistor. So what is the resistor? The resistor resists the flow of current or flow of electrons. So resistivity. What is the difference between the resistor and the resistivity? Resistor is denoted by letter capital R or a small r. Capital R is for resistance and small r is for the internal resistance. Resistivity is denoted by letter rho. What is called the resistivity means the ability of a material to resist the flow of electrons or flow of electric current. So each material has different ability to resist the electrons. So resistivity means the ability of the material to resist the flow of electric current. So let us consider the conductor. Okay, electrons are keep on moving, so current will be increasing, temperature will be increasing. So I want to avoid this temperature, so I have to use a resistor. So what kind of material, what type of material we are using means it depends upon the resistivity of the material. So I'm telling the diamond is not a conductor, it is an insulator. Why it is an insulator means the diamond conductive property is 10 power 24, that is the resistivity property of a diamond is 10 power 24 times more than copper. Are you able to understand? 10 power 24 times more than the copper. That means what? Copper has less resistive property compared to what? A diamond. So if the resistive property is more, what happened? The conductive property is, resistive property is more means conductive property is less. So less conductive property. And here copper less resistive. Less means what? It offers more current. So more conductive. So what is the relation between the conductive and the resistors is resistive and conductive property is what? Inverse proportional. If conductivity is more, the resistivity is less. So copper is a good example for that. So diamond is an insulator. Are you able to understand why we are saying diamond is an insulator? Because it is 10 power 24 times resisting the flow of electrons, resisting the flow of current compared to a copper. That's why if it is resisting more means less amount of electrons. Less amount of electrons, there are very negligible amount of current. So it is not a conductor. So diamond is a insulator. Okay friends, so these are the differences between the conductor, semiconductor, insulators. If you like my video, please subscribe and like the Darren's channel. In case if you have any doubt or any clarification, please ask in the comment box. Okay, thank you.